Alright, so in this video I'm going to talk about the graph of y equals sine of x and y equals cosine of x and draw it so that we can see what it looks like and talk about a few of the characteristics of these graphs. So let's say I have y equals sine of x. If I want to graph this, then I could think about this as being my x, or my angle going inside, and this is my output, or my y value. So let's say I want to take the sine of 0. Now if I have 0 radians and I take the sine of 0, then you can think about your unit circle, and the y value at 0 radians is 0. So that gives me the point 0, 0. If I think about some of these other angles, like for example pi over 6, the sine of pi over 6 would give me 1/2. So if I think about maybe up here being 1, 1/2 being right here, and I could plot that point. At pi over 2, which is at the top of my unit circle, sine is 1. At 5 pi over 6, sine is back to 1/2. We're now in the second quadrant. At pi, or 180 degrees, we're back at sine being 0. And then in the third quadrant, we have these same values, but negative. So we end up with, for 7 pi over 6, it's negative 1/2. For 3 pi over 2, negative 1. 11 pi over 6, negative 1/2. And for 2 pi, back to 0. So one cycle or rotation of our sine wave would look like this between 0 and 2 pi. And because past 2 pi our angles are just coterminal angles that repeat these values, this same pattern would continue in this direction, and it would continue also in this direction if we wanted to sketch any more of it. Okay, so this is what a sine, y equals sine of x would look like if I graphed it on my calculator. And we have a few characteristics that we talk about for sinusoidal waves. So our period is the amount for one cycle of our wave. So in this case, our period would be 2 pi. Okay, our amplitude is the distance from our midline to our maximum, or our midline to our minimum, or half the height of the wave. So because my midline is here and I'm going up, my maximum's at 1, my amplitude would be 1. And my midline, like I already mentioned, is this imaginary line that would cut my wave in half. So right now my midline is at y equals 0. Okay, so for a normal y equals sine of x graph with no other transformations, these would be the period, amplitude, and midline of my sinusoidal wave. As we start to either multiply times something on the outside, multiply on the inside, or add or subtract on the inside or outside, we're going to be stretching, compressing, and shifting this sine wave, and this period, amplitude, and midline would change. Let's talk about y equals cosine of x. Okay, so now we're thinking about if I look at these same angles, or if I look at some different angles around my unit circle and plug them into cosine, what would I get as my output? And for cosine of x, remember on your unit circle you're looking for your x coordinate. So if I think about at 0 radians, my x coordinate would actually be up at 1. So I get the point 0, 1 when I plug in 0 to cosine. If I think about pi over 3, the cosine of pi over 3 would be 1/2. The cosine of pi over 2 would be 0 up at the top of my unit circle. Cosine of 2 pi over 3 in the second quadrant would be negative 1/2. And this will continue. Pi would be negative 1. 4 pi over 3 back to negative 1/2. 3 pi over 2 back to 0. 5 pi over 3 in the fourth quadrant, our cosine is back to being positive, positive 1/2, and 2 pi we're back to 1. So we end up with a wave that looks like this. Okay, and again at past 2 pi our angles would just start to repeat this same pattern and this way as well. So we would end up with a wave that looks something like this for cosine. Okay? For our period, amplitude, and midline, let's take a look at those. Very similar to sine. One full rotation, or our period, is going to be 2 pi. Our amplitude, or our distance from the middle to the top, or the middle to the bottom, is going to be 1. And our midline is going to be the center of our graph, which is right here at y equals 0. So the period, midline, and amplitude are the same for cosine as they were for sine. And again, as we do transformations of this function, those characteristics would of course change.